For thousands of years, humanity looked at the night sky and saw only points of light. We knew the planets in our own solar system, but we had absolutely no way of knowing if any other worlds existed in the darkness. That changed when astronomers confirmed the existence of exoplanets, planets orbiting stars far beyond our own sun. It turns out they aren't rare cosmic exceptions. They are everywhere, and they are incredibly diverse. We found massive gas giants, tiny rocky worlds, planets that hug their stars tightly, and others that orbit far out in the cold. To find life as we know it, astronomers look for something very specific. This diagram shows a star surrounded by a green band known as the habitable zone. This is the exact region where temperatures allow liquid water to pool on a rocky planet's surface. But proximity to a star isn't a guarantee. Venus and Mars sit near the edges of our sun's habitable zone, yet neither has the atmospheric chemistry or energy sources to support a thriving biosphere today. Habitability requires a very specific recipe. Even with strict conditions, the sheer scale of the math takes over. As the animation zooms out, you see those green bands multiply. With billions of stars mostly hosting planets, potential homes for life are impossibly huge. Based strictly on the vast amount of available real estate and the laws of probability, our cosmos should be an extremely crowded place. Life should be the rule, not the cosmic exception. But that expectation collides with a timeline problem. The universe has been around for billions of years, making Earth relatively young by comparison. If a species evolved on a habitable world and developed technology 1,000,000 years before us, they would have an enormous head start. Their engineering and communication networks would be glaringly obvious across the galaxy. This brings us to a famous puzzle articulated by physicist Enrico Fermi, pictured here. He looked at the high probability of extraterrestrial life and the immense age of the universe and asked a very simple question: where is everybody? Because despite scanning the sky and listening for decades, we've found absolutely nothing. No radio signals, no alien structures, no evidence of anyone else. This complete silence breaks our mathematical models. It leaves us with a terrifying vacuum, an empty sky that desperately demands a scientific explanation. To solve this, we have to look at how we actually search for life without leaving our planet. We do it by catching the starlight that passes through the atmospheres of distant worlds. What we are looking for is called a biosignature. This visualization shows how scientists split that passing starlight into a spectrum. Different gas molecules absorb specific wavelengths of light, leaving missing bands. If we see a specific combination of gases missing, like oxygen and methane, it could indicate biological activity below. The catch is that nature is highly inventive. Volcanic activity and complex chemistry can produce similar gas mixtures entirely without biology. A biosignature is a compelling clue, but it is not definitive proof.
Which is why some scientists suggest we might be looking too far away, and that we should start right here in our own solar system to see how life adapts. Simple organisms don't necessarily need a warm, rocky surface. Here, we see Jupiter and its moons against the planet's atmospheric bands. Moons like Europa, along with Saturn's Enceladus, hide massive liquid oceans beneath kilometers of solid ice. If alien life is common, but trapped in absolute darkness under a frozen crust as simple microscopic biology, it's never going to build a radio transmitter to say hello. There is a much darker explanation for the silence. Look at this evolutionary timeline. The Great Filter Theory suggests that somewhere on the long path from basic chemistry to an interstellar civilization, there is a step that is nearly impossible to pass, a massive, impassable barrier that almost every world fails to cross. The existential question is, did Earth get incredibly lucky? Is the hardest step behind us, hidden in the rare leap from single cells to complex animals? Or is the great filter still waiting for us in the future? That future filter could be our own technology. It is entirely possible that advanced civilizations inevitably destroy themselves through nuclear conflict, massive environmental collapse, or runaway artificial intelligence long before they can travel between stars. But perhaps we shouldn't be so fatalistic. There is a chance these civilizations are out there right now, and our perception is simply too primitive to notice them. For decades, humanity has relied on tools like the massive Arecibo observatory dish shown here, sweeping the cosmos for artificial radio waves. But why would a civilization millions of years older than us still communicate using basic radio? They might use physics we don't yet understand, or exist in forms completely separate from biology. The silence of space doesn't necessarily mean the room is empty. We might be looking at the ashes of an evolutionary bottleneck, or we might just be deaf to the frequency the rest of the universe is broadcasting on. No matter the reason, the current reality remains unchanged. We have listened, we have scanned, and the cosmic silence remains absolute. Still, the search is expanding. Telescopes like the Hubble Space Telescope, pictured here, along with next-generation observatories, are looking deeper into the atmospheres of distant worlds than ever before. If they succeed, the stakes are almost impossible to overstate. Catching a single, undeniably artificial signal would confirm that we are part of a larger, populated cosmos. It would prove we aren't alone. But what if centuries pass, we explore thousands of planets, and we hear absolutely nothing? If intelligent life is truly that rare, it means Earth is a statistical anomaly, a completely improbable accident in an otherwise silent universe. And that gives our existence a profound weight. If we are alone, humanity is the only mechanism the universe has to understand itself, which makes protecting this fragile, lonely planet the most important responsibility in reality.